Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 3 current electricity. Today we are going to study about one more instrument and that is potentiometer. In the previous class we studied about meter bridge. Today we are going to study about potentiometer. This is the last part of current electricity. You can remember meter bridge works on the principle of Wheatstone's network. Wheatstone's network consisting of 4 resistors connected in a cyclic order, and the balancing equation is P divided by Q is equal to R divided by S. Using this Wheatstone's network, meter bridge works, and this meter bridge is used to determine unknown resistance of the wire, where unknown resistance of the wire is always connected at the left gap of the L-shaped thick metallic strip. And standard resistance box is always connected at a right gap of this metallic strip. So we studied in the previous class in detail about meter bridge, and I also uploaded the practical video related to resistivity of material of the wire. I hope you all watched that video because you are going to do the practical regarding resistivity of material of the wire using meter bridge in your board examination. Today we are going to study about potentiometer. Again, remember this instrument you are going to use in your practical. Right? Now let us study about potentiometer. So what is potentiometer? It is a device, it is an instrument. It is used to measure the EMF of a cell, to compare EMF of two cells, and also to determine internal resistance of the cell is called potentiometer. Yes, what is potentiometer? Potentiometer is a device which is used to measure EMF of the cell. Right? Yes, what is EMF of a cell? We already studied about the cell, EMF, internal resistance and terminal voltage. That 4 terms you can remember here. Here, this potentiometer is used to determine EMF of a cell. EMF, electromotive force. What it mean? This is potential difference between two terminals of a cell when the circuit is open. When you start to use the cell, then we are going to use a terminal voltage. Right? Now, potentiometer, this device we are going to use to measure EMF of a cell. That is, to compare EMF of the two cells and also to determine internal resistance of a cell, we are going to use potentiometer. Yes, what is the use of potentiometer? Potentiometer is used to measure EMF of a cell. Right? Then, it is used to compare EMF of two cells. We can compare EMF of two cells using potentiometer, and also we can easily determine internal resistance of a cell. That is potentiometer. You can observe this picture. So this is a potentiometer, right? Then, what is the principle of a potentiometer? We already studied principle of meter bridge, that is Wheatstone's network. Then similarly, the principle of potentiometer is, you can observe, it states that when a steady current is passed through a conducting wire of uniform cross-sectional area, then the potential difference between any 2 points on the wire is directly proportional to the distance between the 2 points. What it mean? When you are going to consider a steady current, and that steady current is passing through a conducting wire, and that wire is having uniform cross-sectional area. Then, how to find the potential difference? Observe the potential difference between any 2 points. Suppose you can observe there are 2 terminals in this potentiometer, A and B. Between A to B, several meter wire is connected. You can observe here, several meter wire is connected between A and B. Here, the potential difference between any 2 points on the wire, suppose if I am going to move the sliding contact from the terminal A on this wire. This wire is fitted on the wooden board between the terminals A and B. When I am going to use the jockey, or you can call it as a sliding contact, or it is just like a pen, when we are going to slide that pen on this wire, we will get a deflection in the galvanometer. So here The potential difference between any 2 points on the wire is directly proportional to distance between the 2 points. Suppose if I am going to consider the point P on the wire. I am going to slide on this wire. When I reach the point P, the distance between A to P is equivalent to potential difference between AP. That means potential difference V is directly proportional to distance between the 2 points. Is it clear? This is the principle of potentiometer. Yes, what is the principle of potentiometer? It states that when a steady current is passed through a conductor of uniform cross-sectional area, then the potential difference between any 2 points on the wire, we can take A to P. Right? This is directly proportional to distance between the 2 points. This is the principle of potentiometer. Then, now let us consider a long conducting wire of uniform cross-sectional area. We are going to consider a long conducting wire. So here we are going to consider several meter wire. In meter bridge, we considered only 1 meter wire, but in potentiometer, nearly we are going to consider 3 to 4 meter wire, several meter wire having cross-sectional, uniform cross-sectional area. Now, AB is a conducting wire of uniform cross-sectional area A. Where is AB? You can observe the diagram. Between A to B, you can observe the wire will be like this. Between A to B, a conducting wire is connected, right? So here this is having several meters. Then L is length of the wire. Let us consider L is length of the wire, total length of the wire. We can take it as 3 meter. R is resistance of the wire and V is potential difference across the wire. So between A to B, the wire is connected and it is having potential difference V. And I indicates the steady current which is flowing through the wire, and at last rho indicates resistivity of material of the wire. Is it clear? So these are the terms related to potentiometer. Now we are going to consider potential difference across the wire AB. Just I redraw this diagram to understand the concept. Potential difference across the wire AB. Let us take AB. Potential difference across the wire AB is given by, we know that V is potential difference, I is the steady current which is flowing through the wire, and R is the resistance of the wire. V equal to IR, this is potential difference across the wire AB. Or we can write steady current I is equal to, how to write the equation? I equal to V divided by R. Now let us take it as equation number 1. Now let us move that sliding contact on the wire up to the point P. You can observe this diagram. I am going to move that sliding contact from A to P on the wire. Now let us consider a point P on the wire. Now I am going to consider L is length between A to P. Capital L indicates the total length of the wire which is connected in that potentiometer. That is total length. But when we move that sliding contact on the wire up to the point P, so it is having length how much? Let us take it as a small l. Then what is the potential difference across the wire? Potential difference across the wire is V. But between A to P, let us take the potential difference across AP is, let us take it as VAP. What is VAP? Potential difference across the wire AP. Then similarly, it is having resistance RAP. What is the resistance of that wire which is between A to P? That is RAP. See here, V, I and R. These terms are related to total length of the wire. VAP, RAP, small l. These are related to only the part of the wire that is A to P. See here, let us consider, I am going to write, yes. Now let us consider a point P on the wire. Let L indicates length of the wire AP. VAP indicates potential difference across the wire AP. and RAP indicates resistance of the wire AP. We consider only the part of the wire that is from A to point P. Now we can write potential difference across the wire AP. Here initially we wrote an equation for the potential difference across the wire A to B. That is total length. Now we can consider only the part of wire. I can write potential difference across the wire AP is given by the equation. Instead of V, we can write VAP is equal to IRP. That is IRAP. This is related to only the part of wire AP. Or this equation can be written as, I can write here I equal to VAP divided by RAP. Right? Let us take it as equation number 2. I equal to V by R. This is for the wire A to B. I equal to VAP over RAP, that is equation 2. It is for the wire A to P. Now from equation 1 and 2, how to write the equation? Let us write here. From equation 1 and 2, I am going to write I equal to V by R. So V divided by R is equal to, equation 2 is I equal to VAP by RAP. So we can write VAP divided by RAP. Or we can write VAP is equal to, now the equation becomes V divided by R into RAP. Observe the above equation, VAP equal to V into RAP, cross multiply here, divided by R. Now here, let us take it as equation number 3. Right? What is equation 3 here? Yes. Now we know that resistance R is given by the equation R equal to rho into L divided by A. We already studied about this equation. Right? R equal to rho into L divided by A. Or for RAP, we can write rho into small l divided by A. Because this is only for the part of wire, so we can write RAP. So here you can substitute the values. VAP is equal to V divided by R. So we keep as it is. V into RAP value is how much? Rho into L divided by A. Whole divided by R means rho into L divided by A. Just we substituted R and RAP value in equation 3. So which terms will get cancelled? You can observe. Here rho will get cancelled. Area, cross-sectional area A will get cancelled. So the remaining value is how much? VAP is equal to, we can write V into L divided by capital L. V into L divided by capital L, or we can write VAP equal to V divided by L into L. Let us take it as equation number 4. Yes, from equation number 4 you can observe VAP is related to only the part of wire that is between A to P. Potential difference across AP is VAP. And what is L? L is length of the wire A to P. But what about V and L? V is potential difference across AB. Capital L is total length of the wire. So V and L, these terms will not change. These are the constant value. Is it clear? Because this is related to total length of the wire. Total wire we consider total potential difference. But VAP and L, these are not constant. Just we are moving that jockey on the wire. Right? So here V and L are constant. As V and L are constant, so the remaining equation will be VAP is equal to L. That means VAP is directly proportional to L. So this is the principle of potentiometer. You can remember what is the principle? The potential difference between any 2 points on the wire is directly proportional to distance between the 2 points. This is the principle of potentiometer. VAP is directly proportional to L. Is it clear? So you can observe, we consider potential difference across AB. AB means you can observe this diagram. A to B, there is a several meters wire. Total wire we can consider A to B. And the potential difference is V equal to IR or I equal to V divided by R. That is equation 1. But when we move that sliding contact on the wire, so we can take a point P on that wire. So potential difference between A to P is VAP, resistance will be RAP, and the length is small l. Capital L is the total length of the wire. So we came to know that VAP, that means potential difference across any 2 points on the wire, is directly proportional to distance between the 2 points. This is the principle of potentiometer. Is it clear? What is the principle of potentiometer? It states that when a steady current is passed through a conducting wire of uniform cross-sectional area, then the potential difference between any 2 points on the wire is directly proportional to distance between the 2 points. This is the principle of potentiometer. Then next term is potential gradient. Yes, potential gradient means the fall of the potential per unit length of the wire. Potential drop, the fall of the potential per unit length of the wire. That means for 1 meter wire, let us consider here from A to B there is a 1 meter wire. This is unit length. For 1 meter wire, how much potential drop takes place? This is called potential gradient. Yes, what is potential gradient? The fall of potential per unit length of the wire is called potential gradient. Now we can study about construction of a potentiometer. Yes, what it consists? The potentiometer consists of a long conducting wire AB of uniform cross-sectional area of several meter long made of manganese. You can use manganese or constant wire. Sometimes we can use nichrome. So these wires we are using, it is having several meter. Nearly we can use 3 to 4 meters wire. So this potentiometer consists of long conducting wire AB of uniform cross-sectional area of several meter long made of manganese, or you can use constant wire. Then the wire is stretched on a wooden board provided with a meter scale parallel to the length of the wire. On that wooden board they are going to fix a meter scale. This is what meter scale. You can observe the diagram. On this meter scale, they are going to stretch the wire on this wooden board. This is a wooden board. On the wooden board, the wire is stretched, which is provided with a meter scale, and this meter scale is parallel to the length of the wire. Then a strong battery of EMF E is connected between the ends A and B of the wire. Between A and B, a strong battery is connected and it is having EMF E. To control the current, we are using a rheostat. You can observe the diagram. This is a rheostat. Yes, rheostat is also called as variable resistance. Rheostat is also called as variable resistance, and this rheostat we are using only to control the current, because we know that resistance opposes the flow of charges. Automatically we can control the current using rheostat. So rheostat is connected in series with the battery. You can observe battery is connected to K. K means what here? This is plug key. It is just like switch on and switch off of the battery. To save the power, we are using plug key. Then it is connected to resistance. That is variable resistance, which is called as rheostat. It is connected in series to the battery. Then a sensitive galvanometer G is connected through the jockey is connected. So we are using jockey, that is a sliding contact. Through that sliding contact, we are using a galvanometer. You can easily understand about potentiometer when you watch the practical video classes related to potentiometer. It will be very clear because this is just a diagram, but there you are going to use the instrument. So you can watch the potentiometer practicals. I will give you the YouTube link. Watch that video. It will be very clear. So this is all about the construction of potentiometer. So in the next class, we can study the applications of potentiometer. Totally, there are two applications of potentiometer. The first one is comparison of EMF of two cells. The second one is internal resistance of the cell. These are the two applications of potentiometer. So we can study about these two applications in detail in the next session. Thank you.